we are going to use the so-called elimination method. It consists on combining two equations into one. This new equation will contain only one of the variables and it will be easy to solve. For example, the sum of two numbers is 75 and their difference is 23. If we combine these two equations by adding them, we end up with 2x equals 98 because the y's cancel each other out. We have eliminated the y's, so the equation can be solved for x. X is 98 divided by 2, 49. Y must be 26. Let's try that again. A coffee and a tea together cost $8.50. The coffee costs $1 more than the tea. We add the equations and the y's cancel each other out. 2x equals 950, so x equals 4.75. Since the difference is 1, y must be 4.75, take away 1 or 3.75. The coffee cost $4.75 and the tea costs $3.75. Sometimes, however, we need to eliminate one of the variables by adding the opposite. In this other example, adding will not eliminate neither x or y's. But if we minus the second equation, which we can do because all we are doing is multiplying each term by -1, if we do this, we eliminate the y's and we get x equals 2. Since the sum is 10, y must be 8. In this other example, multiplying the second equation by -1 is not going to work. But if we multiply by -2, then we can eliminate the y's. 7x take away 2x equals 315 take away 100. So 5x equals 215. X must be 43. So y is 7. Some pairs of simultaneous equations are not that straightforward. For example, when looking at the coefficients of both x and y in this pair of equations, I can see that they have nothing in common. So what I'm going to do is I'm going to multiply the first equation by 2 and the second equation by 5. Can you see why? Because then we end up with 10 x's, yes, in both equations. Now we can subtract them to eliminate x. 29y equals 725. So y equals 725 divided by 29, which equals 25. We replace y with 25 into, for example, our second equation. That leads to 2x plus 7 times 25 equals 205. To solve for x, we minus 7 times 25 from 205 and we divide the answer by 2. X equals 15. Elimination becomes second nature the more you practice, but it's not the only method to solve a pair of simultaneous equations algebraically. Want more practice? Access full courses, quizzes, and worksheets in the link below. Happy learning!